So this video we're going to be doing some triangle congruency proofs. So we're going to be proving triangles are congruent based on some of the things that we learned last time. Okay, so if I give you this and I'm saying DA is congruent to MA and AJ is congruent to AZ, okay, and we're trying to prove that those two triangles are congruent. So if I'm looking at it, I always give my given statement. Okay, so then if I have to prove that they are congruent, I have all of my different signs, so it's side, 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 angle, side, those types of things to see if we can prove that this is congruent. So it looks like I can make the angle A, vertical angles. All vertical angles should be congruent. So there's our next step. So by side angle side now, we can prove that these two triangles are congruent. Okay, so WX is congruent to YZ, and WX is parallel to YZ. So triangle WXZ, we are trying to have it be congruent to triangle YZX. So we always state our given. And then my next step, so right now I have two sides that are the same. Okay, I could also say, since XZ is sharing XZ, we could say by the reflexive property that those two are congruent, which means we now have two sides. Okay, so now I need it to be either side, 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 angle, side, something like that with my two sides to make it two congruent triangles. So if I have angle WXZ, so WXZ being congruent to angle YZX, so this one, by the alternate interior angles. Okay, so we're going to be pulling some stuff from last chapter, okay, because we have parallel lines. Whenever we talk about parallel lines, we can have corresponding angles, we can have alternate interior angles, we can have alternate exterior angles, same side interior, okay? So we're bringing those back into play. So now we have side angle side, so we can prove, that by side angle side that those two triangles are congruent. Okay, so we always start with our given statement. So KJ is congruent to MN, angle J is congruent to N. Okay, so my next reasoning, it says vertical angles are congruent. Okay, so I'm going to be looking for the vertical angles. So my vertical angle, KLJ, is congruent to angle MLN. Okay, so because they're vertical angles, they should be congruent. Okay, by the angle side, my two triangles are congruent. Make sure you label them in the correct order, with K being in the same spot as M, and J being in the same spot as N, and L obviously being in the same spot in both of them. Like this. Okay, so now we have perpendicular bisectors, because if we remember, these little pictures here show me that we have perpendicular bisectors. So we're going to have some things that are congruent. Okay, so we always start with our given statement. Okay, so our given statement is BD is perpendicular to BA. BD is also perpendicular to ED. Okay, so and we also say AE bisects BD. Okay, so angle B and angle D are right angles by the definition of perpendicular lines, because whenever we have perpendicular lines, we always have 90-degree angles. Okay, we also say all right angles are congruent, so we're going to be talking about this angle here and this angle here. Okay, our vertex is always the angle that's in the center. So we got angle B is congruent to angle D. Okay, by the definition of segment bisector, we can say that BC is then congruent to DC because of the segment being bisected. So the next part, we got angle BCA, so BCA being congruent to angle DCE. Okay, and those are vertical angles. They sit across from each other, so they should be congruent. Oops. Okay, because vertical angles are congruent. And then we have what we're trying to prove. Okay, so I have my angles. I also have my sides being congruent, so we had BC being congruent to DC. Okay, so by the angle side angle, we can make our two congruent angles, or two congruent triangles.